Hi everyone, this is my summary for Unit 7. So just a quick warning, I'm pretty sure that this one is going to be quite long as there's quite a lot of different ideas in here. I'll do my best to try and keep it as brief as I can, but yeah, a warning, this could end up being a long one. So what Unit 7 is about is thinking about a firm and a firm deciding what quantity of output to produce. Now, a really important thing we assume in Unit 7 is that this firm is producing a differentiated product, which means that they will have maybe some monopoly power. And the consequence of that is if they decide to change their level of output, that they're going to have to reduce the price that they charge in order to sell that output, right? So it means that they have price setting or price making power. So that's going to come back and be important later on. But for now, what I want to start with is just in general thinking about the cost side of a firm. Right. So we saw in Unit 6 that what a firm wants to do is always to try and minimize its costs. So we're going to see how it kind of puts this idea of minimizing costs and maximizing revenues in order to figure out what's the way to maximize total profit. So what we're going to do is start off by just thinking about what are a firm's costs and like different quantities to do with its costs. So the first thing is the total cost, which is sometimes referred to as the cost function of the firm. And the idea of the cost function is if we put in a quantity of output that the firm's deciding to produce, that the cost function will then tell us what the total cost of producing that would be. And so this kind of purple curve represents the total cost of this firm or their cost function. And you can see, for example, if they decide to produce 20 units of output, then that's going to cost them $80,000. And as we go to higher levels of output, we see higher levels of total cost. Okay, so that's all the cost function does. Now, we've got an interesting assumption here, or an interesting type of cost function. We see that it starts shallow and then gets steeper, right? It's a convex function. And that's going to have a consequence for marginal cost that we'll see later on. So another important quantity for a firm to consider, and we'll see that when we think about isoprofit curves in a little bit, is the idea of average cost. So average cost is just defined, unsurprisingly, as total cost divided by quantity of output. So we can actually, using the total cost curve, work out what average cost will be at different levels of output. So this is done in this diagram by taking 3 examples. So we look at point A, where the total cost is 80,000, and that's to produce 20 units of output. So the average cost is 80,000 divided by 20, which is, you can see, 4,000. And so at 20 units of output, average cost is 4,000. Now we can do the same thing at different points along this curve. And so at, say, again, at 40, we work out, so at point B, where the output is 40, we could look across the total cost, and we could use that then to work out the average cost. And we see in this case, it's 3,400. And we can do it at a different point, at point D. And we see we get this average cost curve, which falls initially and then starts to go back up. And we're going to talk about why that might be in a minute. But so this is like a typical shape of an average cost curve. Now, one way that we can visually see that this is going to have to happen is another way of thinking about calculating the average cost. Is if we pick point A, we could actually think about forming a triangle from O to A to 20. And then the average cost would actually be the slope of that line that joins O to A, right? Why? Because to find the slope of that line, we do the vertical height, which is actually the total cost, 80,000, divided by the base here, which is the quantity of output. So the slope of that line is just the average cost. And we see the slope of the line that joins O to A is steeper than the slope of the line that joins O to B, indicating average cost at A is higher than average cost at B. And if I did a line from O to D, you would see that it would be sort of in between in terms of steepness, right? And that's why we see average cost then at D is above B, but below A. So those are the first important ideas: total cost and average cost. Now, before I move on, another important thing to be able to recognize is the idea of fixed costs. So if the idea of a fixed cost, it's a cost that a firm has regardless of how much output it produces. So even if it produces zero output, the firm still has to pay those fixed costs. So that could be stuff like utility bills, rent for the building. So things that will not vary depending on the level of output. And we can identify that from the total cost function at this point right here, right? Because we can see at zero output, there is a cost that has to be paid. So that value up there, that represents the fixed costs of the firm. All right, so we got fixed costs, total cost, and average cost. Now let's talk about marginal cost. Oh, actually, no, before we do that, we're going to talk about a justification for why average cost might fall to begin with and then rise again. And the reason that we think this is a reasonable assumption is we think that there are what we call economies of scale and diseconomies of scale when it comes to a firm. So let's have a look at the definitions first. So what do we mean by an economy of scale? So if a firm increases all its inputs, the amount of all of its inputs, or the spending it does on all of its inputs by a given proportion. So let's say a firm has decided to triple or treble the level of all of its inputs. If we then got an increase in the output that was more than triple, right? So we triple all of the inputs, but we actually get an increase in output that's 5 times. We would say that we have increasing returns to scale, or that we are benefiting from economies of scale. And what you can imagine is that when a firm produces more output, as it gets bigger, it might find ways of doing the production process more efficiently, right? It might hire maybe specialist managers who can kind of manage a particular part of the production process really, really well. Or because it's maybe buying more inputs, it can buy them in bulk and therefore buy them at a lower cost. So this is why we think as a firm, kind of, if it starts off small and gets a bit bigger, it might benefit from these economies of scale, which means that something like tripling the inputs more than triples the level of output. And that would then correspond to average cost falling. Because if you think about, say, tripling the input, then total cost maybe should triple. But if that leads to a quantity of output that's 5 times bigger, think about our average cost formula, right? We're saying that the top is getting 3 times bigger, but the bottom's getting 5 times bigger. So therefore the average cost must be smaller, must be getting smaller. Similarly, we can think about decreasing returns to scale or diseconomies of scale. So this is where maybe when we get to higher levels of output, we decide to say triple the level of inputs, okay? But we see that we only get twice as much output, right? So we're getting a less than proportional increase in output. And using the same sort of reasoning as I did before, so if we triple the inputs, total cost goes up by a factor of 3, but we only see the quantity go up by a factor of 2. Well, the numerator's now getting bigger faster than the denominator, so average cost has to be going up in this case. Now, concrete examples of diseconomies of scale, you can think about when a firm wants to produce huge amounts of output, it gets massive, it has loads and loads of workers. Maybe it's hard to coordinate all those different activities. Maybe we're not able to motivate the workers as much as before. So these are all kind of, solid reasons why you might get diseconomies of scale. And just for completeness, we might also have a situation where when we triple the quantity of inputs, we get triple the amount of output, and therefore the average cost is just staying constant. And we refer to that as having constant returns to scale. So not so important for the average cost curve that I've drawn, but economies of scale and diseconomies of scale explain why average cost will fall and then start to rise again. Okay, so with that story in place, now let's move on to the idea of marginal cost. So marginal cost, what do we mean by it? We mean the extra spending you'd have to do to increase the quantity of output by 1. So we again go back to our total cost curve or our cost function. And let's imagine we're at point A. And to work out the marginal cost at point A, what we need to do, as you can see, we zoomed in here. We think about, well, if we moved from producing 20 to 21, what would be the increase in our total cost? And that's what we mean by marginal cost. What's the extra cost we have to incur to produce 1 more unit of output? And we can do the same thing at point D. And zooming in here, you can see really clearly that here, to increase the output by 1, we're seeing a much bigger increase in the total cost than we did when we were down here. And we could go along this curve and work out the marginal cost at every point. And then we could plot those marginal costs. And what we would find with a total cost function that's convex like this is we'd find that we'd have a marginal cost which is increasing and in fact is linear. So a kind of another way that you could see that the marginal cost has to be increasing is think about what we're doing at each of these points. We are looking at the slope of a tangent at each point. And you can really clearly see that because this is a convex function, the slope is getting steeper and steeper and steeper, indicating that the marginal cost must be getting bigger and bigger and bigger. And so that's why we see the marginal cost curve increasing. So before I kind of move on to the final bit of like costs, one really important thing to point out, everything I've talked about so far is based on a cost function that is convex like this, okay? And that doesn't have to be the case, right? Firms in different industries might actually end up having, like a concave cost function, right? But we're going to build all of our ideas on the basis of this convex cost function, because that's actually kind of maybe the most standard case. Okay, so the kind of final thing I wanted to talk about, a little bit of a pause, and the final thing that really links together average cost and marginal cost is this very key idea that you can see when you look at this graph, but that the marginal cost and the average cost curve, they will meet each other where average cost is at its minimum. And it's really important that you're able to explain why that has to be true. So the way that we can do that is let's consider us being here at quantity 20. And we can see at quantity 20, our average cost is up here around about 4,000. And the marginal cost is down here around about 2,000. So let's think about what does marginal cost mean? It means if we were going to move from 20 to 21 units of output, in this case, quantity like number of cars, the marginal cost tells us how much extra money we'd have to spend, right? Now, if you think about what average cost is, it's total cost divided by quantity. Now, if marginal cost is less than average cost, if I went to 21 and thought about working out what the average cost would be here, I would be adding on an extra unit. That extra one has an extra cost which is lower than my current average. So if I worked out a new average, that new average would have to be lower than the old one, okay? And as we move from 20 to 40, we can see that marginal cost is always lower than average cost. And while this is true, while marginal cost is lower than average cost, the cost of every extra unit is lower than the previous average, which means the new average has to decrease as well. So that explains kind of why we kind of see average cost falling while marginal cost is below average cost. And we can use the same sort of reasoning to the right over here. So here we see marginal cost above average cost. And same sort of reasoning tells us, so let's say we're at this point here, right? my average cost is like, I don't know, around about 3,500, but my marginal cost, the extra it's going to cost me to produce one more unit is above that 3,500, which means if I do go to that like point of extra output, then I'm going to add an extra cost, which is above the old average, which means if I work out a new average, it has to be higher. So that same reasoning tells us that while marginal cost is above average cost has to be going up. So put those two ideas together. While marginal cost is below average cost is going down. While marginal cost is above average cost is going up. So the only place where average cost is not going up, not increasing or decreasing, meaning where it's at its minimum, is where marginal cost and average cost are the same, right? Because while marginal cost is below average cost has to fall. While marginal cost is above average cost has to increase. So the only place it can't be either increasing or decreasing, where it's at its minimum, is where they're the same thing, okay? So that's a really important thing to be able to explain. And that's, I would say, the last kind of introductory bit that tells us everything we need to know about marginal cost, average cost, total cost. So what I'm going to do next is talk about how then the firm brings this in to figuring out the level of output it should produce. So before I do that, I'm just going to take a quick pause. Okay, so let me carry on. And all right, so as I said, what we're going to do now is think about how does a firm choose its optimum level of output, okay? And the kind of condition we're going to use to think about how a firm does that is we want the firm to be thinking about maximizing profit, right? So if the owners of a firm are rational, that seems like the sensible thing to do to maximize the level of profit. So in order to figure out the quantity of output where profit will be maximized, let's think about what are called ISO profit curves. So on this graph here, you can see three different kind of blue colored lines that represent different ISO profit curves. And we've seen the term ISO before, it means the same. So what these curves represent are combinations of a quantity of output and a price that would lead to the firm achieving the same level of profit. So if I say take point K and point G, you can see very different combinations of a price they're going to charge and a quantity they're going to sell, but they would lead to the same level of profit. So from the firm's perspective, what do they want to do? They want to be on their highest possible ISO profit curve. Now, the thing that's going to constrain them is going to be about who they're selling to. It's going to be about consumers and about demand. And I'll come back to that in a minute. But one thing I want to do now is just show this connection between ISO profit curves and something that we've seen a second ago, which is costs. Okay, so let me go back up to this really, really crucial equation. Okay, so it tells us that a firm's level of profit is equal to its total revenue minus its total costs. Simple, but really important. So how would we work out total revenue? Well, very important thing, we're assuming that the firm here can only set one price, right? They sell the good, every good they sell is at one single price. So their total revenue is going to be the price for each unit of output multiplied by how many units of output they sell. And then their total costs are given by this. Now, this just represents the cost function, right? It's written C of Q, meaning this is just going to give us the total cost for producing Q units of output, all right? So how can we take this and use it to kind of get a link to ISO profit curves? Well, let's imagine that we want a constant level of profit that I'll call K. And then we've got, so PQ minus CQ, which I'm actually going to change to be TC, okay? And the graph that I showed you below showed us a relationship between price and quantity. So to get ISO profit curves, we need to get a relationship between price and quantity. So let's use this right here and do a little rearranging to get that relationship. So what I'm going to do is bring PQ, well, I'm going to just do a bit of rearranging to get that PQ is equal to K, this constant level of profit, plus TC, the total cost. And now, if I divide both sides by Q, the quantity, I get that the price is equal to K, this constant level of profit, over Q, plus TC, the total cost, over Q. And one final little thing now, so the price is equal to a combination of some constant over Q plus TC over Q plus average cost, right? Total cost over quantity is average cost. So we can actually see here that ISO profit curves, they are just a combination of the firm's average cost and then this other function, which is some constant over Q. Now, final really important thing to see is if we set the level of profit K to be equal to 0, then this actually just becomes price is equal to average cost. So the ISO profit curve for 0 profit is just the average cost curve. So just to, let me go back down to the diagram, and you'll actually see if we look at what's called the 0 economic profit curve, the ISO profit curve where K is equal to 0, you can see in brackets it says AC curve, and I've just shown you why that's the case. And then another connection here, if we look at the marginal cost curve that's been plotted, it is going through this point B, which we know has to be the minimum of this average cost curve, right? So that's our first ingredient in terms of thinking about the level of output, the quantity of output that a firm would choose, right? We've got these ISO profit curves, and we know the firm wants to maximize its profit, so it wants to be on the highest possible ISO profit curve that it can get to. So the other ingredient we need is the demand side, the consumers, right? And that's going to come from what we call a demand curve. And what the demand curve shows us is, you can see it's this red line right here. It shows us that, for example, at this price, at a price of $8,000, that we would have, I mean, simplifying this a little bit, we'd have basically one person who'd be willing to buy the car, willing to buy the output. If they drop the price lower, then we'd have a higher level of cars that we could sell, right? And you can see as the firm lowers the price, they can sell a greater quantity of output. Or to put it differently, as the firm lowers the price, there are a higher number of consumers who are willing to pay for that output. Again, in this case, cars. So that's what the demand curve shows us. It shows us at every price how many consumers would be willing to pay that price and buy the car. And that's why the demand curve is our constraint here, right? It's the thing that constrains how much profit the firm can make. So how does a firm decide what is the level of output, the quantity of cars in this case, that's going to maximize their profits? Well, remember, they want to choose a quantity of output that will get them to the highest possible ISO profit curve. And we're back to our old thing again, MRT equals MRS, right? So MRT, we think of as the slope of the demand curve, right? Because it's the transformation of sort of price into quantity or quantity into price. It tells us the sort of trade-off for the firm that if they decrease price, how many extra cars can they sell, right? That's what we mean by the MRT. And the MRS is about the it's about the ISO profit curves. And the MRS is telling us, from the firm's perspective, what would they be willing to substitute, right? So it tells us their willingness to substitute a lower price for a higher quantity. And unsurprisingly, we can see just like from the diagram here that to get to the highest ISO profit curve, we want the quantity where the demand curve is a tangent to an ISO profit curve, and that's going to be at point E, and that's going to be where the marginal rate of substitution, which is the slope of the ISO profit curve at this point, where that is equal to the marginal rate of transformation, which is the slope of the demand curve at this point. But the fact that the demand curve is a straight line means the slope is the same everywhere. But if we can find the point where the slope of the demand curve is equal to the slope of a tangent to an isoprofit curve, that's going to be where MRS equals MRT, and that's going to be the quantity of output that the firm should sell, and it also tells us the price they should sell at. And that's going to allow them to maximize their profits. So that is one way we can think about a firm maximizing profits. There is actually another, which I'm going to talk through in a minute or two. But maybe one other thing to point out here is the fact that the demand curve here is downward sloping. That is due to the fact that we have a firm selling a differentiated good. We have a firm who have a bit of monopoly power, which means if they want to sell more, they're going to have to lower the price, right? That they have, because they have this market power, they have the power to set price. So if they want to sell more, they're going to have to change the price to do that. Yeah, so that's why we have a downward sloping demand curve, which we'll see a contrast with that in unit 8. But yeah, I won't go into that too much more now. So let me take a quick pause, and after that pause, we'll talk about a different way we can think about how a firm maximizes their profit. Okay, so what I want to do is now talk through a second way that we can think about how a firm decides to maximize its profit. And that comes from this condition, which I've written up here. So it's finding when the marginal revenue, so the quantity of output, where the marginal revenue is equal to the marginal cost. Now, marginal cost we've seen before, that's the kind of extra cost if a firm decides to produce one more good. Marginal revenue we haven't seen before, but same sort of idea. It is the extra revenue a firm would gain from producing and selling one more unit of output. So how do we kind of like find the marginal revenue curve? Well, that's what I want to just talk through here. So if we start with our demand curve, and let's imagine that the firm is at point A. So they're producing 10 cars and they're selling them all at a price like slightly above $7,000. So to work out the marginal revenue, we need to think, well, how much extra revenue would they make if they sold 11 cars? So there's two things to bear in mind here. If they are going to sell an 11th car, then they're going to have to drop the price of all of the cars that they sell. Okay, so that's going to mean on all of the previous 10 cars, they are going to get a lower price. And so that's going to be a bit of a loss. And that's what this like little purple bit here represents. So maybe one important thing I should have mentioned. How do we work out revenue from this? The revenue, remember, is the price times the quantity. So actually, if we're at point A here, the revenue would be this kind of rectangle, which I'm drawing really badly here, right? That rectangle there. If the firm decides or wants to think about the marginal revenue, it would think, well, what would our revenue, what extra revenue would we get if we moved to 11 over here? And as I was saying before, that's going to lead to a lower price for the 10 cars. So that's going to be a loss of revenue, but then they sell an extra car at this new price, and that's going to be a gain of revenue. And that is what will allow us to work out the marginal revenue. And so if you did that, you could then actually plot out what that would be. You can see that's what's been done down here, right? So we're seeing a positive marginal revenue. And we can do the same thing at different points, right? So say we're at point B, we think about, okay, so point B is 20 cars, let's work out the total revenue there, right? Which would be this kind of pink rectangle there. Then let's work out what's the total revenue if you move to 21. And that's going to be this slightly like this blue rectangle. And so we could work out the difference between those. And really what we're thinking about is that little pink bit at the top, that's the loss from having to lower the price of the 20 cars. And then this blue bit here is the gain from having sold an extra car. And you can see it's the same idea as we look at points like E, C, and D. And we can use that to plot this marginal revenue curve, right? And then if we have a marginal revenue curve, it turns out that profit is maximized at the quantity of output where marginal revenue is equal to marginal cost, right? And that's going to be at point E here. So why is that true? Okay, well, we need to think about this in a similar way to how we thought about the marginal cost and average cost idea. So let's imagine that the firm is at this point here. They're producing 10 units of output. So here, the marginal revenue, the extra money they would make from selling one more is up here. It's like 6,500. And the extra cost that they'd have to incur to make that extra car is down here near like 1,000. So if they're at 10 and they decide to make 11 cars and sell that 11th car, they are going to get a lot more extra revenue than the extra cost that they have to pay. So if that's true, they cannot be maximizing their profit, because if they made 11 cars, they'd make some extra profit. And as we move towards, say, like 30, as we move towards point E, we can see the firm always has this ability to make an extra bit of profit, right? Because as we move from 10 to 20 to 30, the marginal revenue, the extra money they're going to make from selling one more car is always higher than the extra cost they have to incur. So while that's true, their marginal profit is positive. By marginal profit, I mean the extra profit they can make from producing and selling one more car. And below here, you can see that we've plotted the profit that they can make at different quantities of output. And you can see at 10, we've got a positive, we've got positive profit, but we can also see that the profit is increasing. And so while marginal revenue is bigger than marginal cost, profit is on the increase because marginal profit is positive. And when we get to point E, we see that that is the point where not only marginal revenue and marginal cost are the same, but the point where the total profit has reached its peak. So why does total profit start to fall after that? Well, we can see if we go beyond point E, marginal cost is now higher than marginal revenue. The extra cost from producing one more good is higher than the extra money you could receive for selling that good. So that means once we go past point E, marginal profit has now become negative, okay? And that is why the total profit will start to fall. So put those two ideas together. While marginal revenue is bigger than marginal cost, there's more profit to be made. So you have an incentive to make more, to produce more output and sell it. While if marginal revenue is below marginal cost, that's really bad, because now you are selling a level of output where you're actually you're selling output that's costing you more to make than you're making from selling it. So the sensible place has to be where you're dead in the middle, where the marginal revenue equals the marginal cost. And that's where your total profit is maximized. So that's the other way you can think about a firm maximizing profits, where marginal revenue is equal to marginal cost. So the next thing that I'm going to talk through is a few ideas. So we're going to talk about what we mean by consumer surplus, producer surplus, and then actually we're going to see why, when we have firms that, or a firm that is selling a differentiated good and has some monopoly power, we're going to see that they actually end up choosing a quantity of output which is Pareto inefficient, right? Meaning it is a level of output where it would be possible to make both the firms and the consumers better off. So let's first of all talk about consumer surplus. So we can see from this picture that the firm is going to choose a quantity of output equal to 32. Why? Because that is where the demand curve is a tangent to the highest possible ISO profit curve. And so they're going to sell their cars at a price of $5,440. And so P star, that's our price level. What we mean by consumer surplus is sort of the benefit that consumers are getting. So we can see that the first car that was sold, we actually have a consumer who was willing to pay a much higher price, but they're actually only paying this lower price, 5,440. So that gap there is sort of a big benefit to that first consumer, right? They feel like they've made a big saving. And if we go to the second consumer, all right, they would have been willing to pay, again, a much higher price. And as we move along, every unit of output that's being sold, the person who's buying it would have been willing to pay more. So they all feel like they're making a saving. And so if we work out this area here, that represents the sort of total saving or surplus these consumers feel like they are making. And that's what we mean by consumer surplus. Now, producer surplus, really similar idea. So here we look at the difference between the price that the firm receives and how much it costs them to produce that extra unit of output. So again, we could think about, well, that first car, right? That first car cost this much to produce, but they sell it at $5,440, a much higher amount. And so that gap there represents what feels like a big profit, a big kind of extra profit to the firm. And as we work our way towards the actual quantity of output, right, every kind of gap between the price they sell it for and how much it costs them to make, all of that is what we call a surplus to them and what we call the producer surplus. So that's why you can see this kind of like, I don't know, reddy pink area that represents the consumer surplus, this like benefit for the consumers. And this kind of purple area represents the producer surplus, the benefit for them. So now we get to the idea of why this is Pareto inefficient. So there's a couple of ways to kind of think this through, right? So the place we need to start is to think and remember that the firm has to set a single price for every good that they sell, right? This is kind of maybe a rule in the market that they cannot sell goods to different consumers at different prices. They have to set just one price. So the price they decide to set is this one, and that's because this is their profit maximizing quantity and price. But actually, there would be a price and a quantity that would make both consumers better off, and you could argue make the firm better off, right? But only, this is really crucial, only if they could change the rules and sell the cars at different prices to different consumers, right? So if they could do that, then the 33rd, if they could sell the 33rd car at this price here, lower than 5,440, then we have an extra consumer who is buying a car, right? That's a benefit for them, right? We have another consumer who's got a good that they want, right? So that we're kind of benefiting the consumer side. But this also benefits the car firm, the supplier, because if they sell this 33rd car at this price, right, that price is well above marginal cost. So they're making a profit on that car, right? But this only works if they can sell that 33rd car at this lower price, okay? But in the rules that we have, they can't do that, okay? If they want to sell the 33rd car, they would have to lower the price of every car that they've sold before. And they don't want to do that because that would lower their possible profit, right? So that is why we end up at this Pareto inefficient quantity of output, because in order to maximize their profits, given that they have to set one price, they actually sell a quantity which is lower than the Pareto efficient quantity. So where is the Pareto efficient quantity? It's actually going to be right here, right? So it would be a quantity Q0, a price P0. And this would be Pareto efficient. And the way that I want to think about it is because if the car firm produced this quantity and sold at this price, then what would happen to our consumer surplus? Well, the consumer surplus would still be this red area, but it would also include this red area, and it would also incorporate that red area there, right? So consumer surplus gets much bigger, right? We can see consumers are better off. And then in terms of the producers, yes, they have lost out on this. They've gained this though, right? But you can actually see why this is another reason why the producers don't want to do this, because it's very clear that this red area, this area here, is bigger than this, right? That they would sort of lose out from this, because they would gain a bit of surplus here, but they'd lose this much bigger one. So why am I saying that this is Pareto efficient? Because if we look at the total surplus, right, the producer plus the consumer surplus at this level of output, it's now the maximum it could possibly be, right? And if we're at point F, and I thought about, well, why don't we move to a higher quantity, right? Then this would make somebody worse off. In fact, it would make the car firm worse off, because if we went to a higher quantity, then they would be selling at a price that is less than their marginal cost. So they'd be losing money. Now, the consumers would be better off because we've got more people buying cars, but this means that to go upwards from point F to a higher quantity, we have had to make somebody worse off. We've made the firm worse off in order to make the consumers better off, okay? And if we think about now going the other way, back down, if we do that, we are making it so that the firm is able to sell at a higher price, okay? So they're better off, right? We're making the producer surplus bigger, they're better off, but now the consumers are losing consumer surplus, they're worse off. So to go to the left of point F, we have to make the consumers worse off in order to make the producers better off, right? And so moving away from point F, the only way we can do it is to make one person better off, one side of the argument better off by making someone else worse off. And if that condition holds, we must be at a Pareto efficient allocation. So F is the Pareto efficient point, but the firm decides to produce at point E because that's the one that maximizes their profits. That's the one that maximizes their producer surplus. And they're doing that at the expense of the consumers. And so actually what we see in a market with a differentiated good, we actually see a market failure. We see a quantity of output chosen, an equilibrium quantity that is Pareto inefficient. And that is the definition of a market failure. Okay, so I'm still not quite finished because there's actually one more really important concept that I'm going to talk through, and that is the idea of elasticity. I'm going to talk about how elasticity relates to marginal revenue, and then how elasticity can tell us about the size of the dead weight loss. And that actually reminds me, I didn't really refer to it, but so we said if the car firm produced at point F, then that would maximize the total surplus, right? We'd have this whole sort of triangular area, which would be consumer surplus plus producer surplus. But the actual equilibrium is here. And we see we're losing out on some consumer and producer surplus, and we refer to that as a dead weight loss. So in like the last thing I'm going to talk about, I'll relate elasticity to marginal revenue, and then we'll see how elasticity is actually quite important for thinking about the size of the dead weight loss. But before I go to that, I'm just going to take another pause. Okay, so the last sort of set of ideas I'm going to talk about in this video is bringing elasticity into things. So first off, what do we mean by elasticity? So we use this symbol epsilon, and we define it as minus, and I'll talk about why there's a minus in a second, the percentage change in demand. And what we mean by that is the percentage change in the quantity that's demanded divided by the percentage change in price. Okay, so where this can come in handy is if a firm, say, decided to increase their price, then we looked at what happened to the quantity demanded. The elasticity would tell us this kind of responsiveness of the demand to the change in price, right? That's what the idea of this is. Now, why the minus? Well, this is kind of just a convention that we want elasticity to be a positive number. So say we know that the price is going to go up, right? The percentage change in price will be positive. And we would expect with most goods, when they get more expensive, the quantity demanded would go down, would decrease. So if the bottom is positive, and if the denominator is positive, we would expect the numerator to be negative. So this would give us a negative overall. So we stick the minus in front to make sure this all comes out as positive. So elasticity in itself can be quite a useful thing to work out because it gives us this measure of how responsive demand is to a change in price for a good. And that's something that firms could be interested in. But to connect it now with something else we've been talking about, let's think about elasticity and marginal revenue. So what I want to do is just kind of look at how elasticity changes as we move along the demand curve. That might seem strange, but actually just with some simple calculations, we can see that elasticity will change. So let's imagine we're at point A and we think about, so point A, quantity of output or the quantity of consumers is 20. So let's think about moving to a 21st consumer, having one more. All right, sorry about the noise. Having one more consumer. Okay, in order to do that, the price is going to have to decrease. Now down here in the table, it actually kind of gives us these changes. So quantity is 20, the price at 20 is 6,400. So if we think about a change in quantity of 1, as in getting one more consumer, right, increasing demand by 1, in order to do that, we have to decrease price by $80. So let's use these 4 numbers then to think about percentage changes. So percentage change in quantity, we want to do the change in quantity divided by the original. So the change in quantity is 1, divide that by the original, 1 over 20, and that'll give us like 0.05. We multiply by 100, and that gives us 5%. We can do a similar thing for the percentage change in price, right? So percentage change, the change in price is 80. Divide that by the original 6,400 and multiply that by 100, and we'll get minus 1.25. So then the last step, get the elasticity. It's this, the 5, divided by the minus 1.25, which would give us minus 4. But then we multiply that by minus 1, and it gives us 4. So we've seen that at point A, we have a elasticity which is 4, much bigger than 1. And 1 I've referred to, and I'll explain why in a little bit, why that's important. But quick comparison is if we also did a calculation of marginal revenue at a quantity of 20, we would see that our marginal revenue would be positive, okay? And if we now jump to point B, right, and we went through the same sets of calculations, we would see the elasticity has now gotten smaller, but it's still bigger than 1, and the marginal revenue is still positive. And now we jump down to point C, and we work out the elasticity there, and we see it's gone below 1, and the marginal revenue is now negative. And this is what's indicating a kind of important link between marginal revenue and elasticity, which is where the elasticity is 1, the marginal revenue will hit 0, okay? That's the really important link that we want to just like emphasize. So where elasticity is 1, marginal revenue is 0, right? So maybe like a final thing on this, why is that happening? Well, kind of let's think about what is the link between these two things. Well, in order to get an extra consumer, you have to lower the price, right? And when we're doing that, right, we are losing out on a higher price from those previous goods we'd sold, but we sell one more. So we want to do that. We want to keep lowering the price and increasing the quantity while the marginal revenue certainly is positive, right? And definitely while the marginal revenue is above the marginal cost. And so that's why this link can be quite helpful, right? Because if elasticity is bigger than 1, we know marginal revenue is positive. So that might indicate that we want to keep lowering the price and keep selling a bigger quantity. And certainly when marginal revenue becomes negative, we definitely don't want to keep lowering the price. So that's kind of like a reason why this is quite a useful link to know about. Now, the very final thing is to think about how elasticity might relate to the level of inefficiency in a monopoly market, or a market where the firm has some monopoly power. So it should be, I hope, pretty clear that the elasticity of a good, yes, it changes along the demand curve, but also the elasticity at those different points along the demand curve will depend on the slope of the demand curve, right? So here you can see that this demand curve represents a good that has quite elastic demand. You can see that just simply by, if we drop the price kind of by this relatively, well, actually it's quite a big amount, but like, let's say relatively small, we would actually see a very, very big increase in demand, right? So that indicates to us value of elasticity, right? The percentage change in the quantity demanded is going to be much bigger than the percentage change in the percentage change in the price. And let's now compare that to the graph below, where we have inelastic demand. And inelastic demand, you'll definitely see, or you'll know that that's the case when the demand curve is quite steep. And that's because here, if we had, like, you know, let me do a relatively similar sized arrow to before, we have that drop in price, we actually only get a relatively small increase in demand. And actually, why this is a kind of a useful thing to know for a firm, that actually means if they do an increase in price, they're not going to get that much of a drop off in the demand. So really useful for a firm to know that. But the connection with the inefficiency before is, if we have a good with quite elastic demand, the firm knows that, yes, they want to produce at a quantity that maximizes their profits, but that quantity actually won't be too far away from the equilibrium, right? That they can't, sorry, it won't be too far away from the Pareto efficient equilibrium. So when the demand for the good is elastic, they cannot increase the price kind of too much, or else they're going to reduce demand a lot. And you can see here this term profit margin, right? So profit margin is the difference between the price that they get and the marginal cost. And you can see when we have an elastic demand, that profit margin is not that big. Whereas with inelastic demand, the monopoly firm, or the firm with monopoly power, they are able to make much kind of better use of the fact that they have this inelastic demand. And you can see that actually the profit maximizing quantity here is further away from the Pareto efficient quantity, but it's also going to lead to a much bigger dead weight loss, right? Much bigger dead weight loss, a much bigger reduction in the total surplus compared to that Pareto efficient point. So just to kind of do a final comparison, dead weight loss for this elastic good, quite small actually. So the market failure here is not so bad, but the market failure when we have a good with inelastic demand is much bigger, really much bigger. So that's the final connection, how elasticity of a good can have an impact on the size of the market failure. Right, let me finish up with unit 7 there. Sorry, it was so long, lots of key ideas in it, but again, I hope that was really helpful.